This is the problem that we use to introduce the ideas of what we're going to be doing for Lagrange multipliers. What I would like to do here is just work out all the details to actually see what a solution would look like. Now remember, we have a profit function, we have a constraint equation. What we want to be able to do is write down the equation, the gradient of f is equal to lambda times the gradient of g, and just see what that entails. Well, I know how to find the gradient of f. It's just the partial of x, and that's y, and the partial of with respect to y, and that's just x. And I'm supposed to put a lambda down. Gradient of g with respect to x is 2x. The gradient of g with respect to y is 4y. Didn't say that right. This actually gives us two equations, because this gives us the equation y equals lambda times 2x. And it gives us another equation. It gives us x equals lambda times 4y. Now that's two equations and three unknowns, but we have our constraint equation, and so we're going to throw that into the mix. X squared plus 2y squared equals 4, like this. Now some videos just start going forward, but most books actually at this point ask us to solve for lambda and start to draw some conclusions. Now if I take that first equation and solve for lambda, I'm going to get lambda equals y over 2x. Now the only problem with doing that is that what we just did is divided by x, and we didn't know if x was 0 or not. So basically what I would do with all of these, I have what I call an oh crap list. Now the problem is that this is perfectly valid as long as x is not 0, and what's going to happen is I'm going to have to worry at the end about oh crap, what happens if x equals 0? In the second equation, if I solve for y, I'm going to get x over 4y, which is perfectly valid as long as y isn't 0. At the end, I'm going to have to worry about what happens, oh crap, if y equals 0. Now, we'll worry about that when we're all done. Now, once I get this equation right here, what we can do is just cross multiply. I'm going to get 4y squared equals 2x squared. That's the same thing as saying 2y squared equals x squared, like that. And now I can plug that back into equation 3. Let me put a little, say by equation 3. So what I'm going to get is x squared plus x squared, that's 2x squared, equals 4. Or x squared equals 2. Or x equals plus or minus 2. Like that. Now that being said, we need to solve for y. We do know that y is going to have to be plus or minus the square root of x squared over 2. I'm just trying to do this right here. So divide by, yes. So what are we going to get here? We're going to get plus or minus. That's going to be 4. That's going to be plus or minus square root 2. Like that. And so that gives us 4 points to have to worry about, right? That's going to give us plus or minus 2, plus or minus square root 2. And that's all well and good, except for the oh crap list. What can happen if x equals 0? So I'm going to come over here like this, and I'm going to start in turn considering each of these things in the oh crap list. What happens if x equals 0? Well, if x equals 0, I'm going to come way over to equation 1 right here. Right? If x equals 0 right here, that's going to mean y equals 0 too. So that implies that y equals 0. But if x equals 0 and y equals 0, I'm going to come back down to equation 3 and says that doesn't work. So 3 says no. So I don't have to worry about that. If x equals 0, equation 1 tells me that y equals 0. If they're both 0, like that would entail, then equation 3 says no. So we don't have to worry about x equals 0. We've already taken care of it. What happens if y equals 0 in this case? Well, if y equals 0, I'm going to come back over here to equation 2 and say that x equals 0. So I'm going to say equation 2 over there is going to imply that x equals 0. However, if x equals 0 and y equals 0, I'm going to come back over here to equation 3. And over here with equation 3, we say that it doesn't work, because 0 squared plus 2 zeros squared is not 4. 3 says no. So we get to eliminate y equals 0 from our list. Now what do we have? What we have are essentially 4 critical type points where we know the function is as big as possible has to come from this list, and where the function is as small as possible has to come from this list. And so we're going to have to finish this problem by plugging in each of those points and seeing which ones give maxes and which ones give mins and which ones don't give either. So to finish the problem, I need to make a table. And the function here is just xy. And so what we're going to get, how about is here is 2 square root 2 and 2 minus square root 2 and minus 2 square root 2 and minus 2 minus square root 2, and just start plugging in. I'm supposed to multiply x times y, so I get 2 square root 2 minus 2 square root 2 minus 2 square root 2 and positive 2 square root 2, right? That means we have 2 maximums and 2 minimums. Yes, this is a global max. We know that all the maximums have to come from this list, and that's the biggest value. And so this is also a max. These also are mins. Which, by the way, was completely consistent with the picture we drew at the very beginning. We saw that there were going to be 2 maxes, one in the third quadrant, one in the first quadrant. We saw that there were going to be 2 mins, one in the second quadrant, one in the fourth quadrant. So that's a very, very basic example about how we use Lagrange multipliers. We write down the equation, we solve like crazy, we have to compile an oh crap list, which usually is going to be a lot more work than this. We solve for lambda, we find all the points where we can solve for lambda, we go through the oh crap list, we find all the points on that the oh crap list is going to give us, and then in the end we still have to make a table and see which values give us, which points give us the biggest values, which points give us the smallest values.